today we want to talk about user-defined data types. Yeah, user-defined data types. This is gonna be a very important topic as far as your paper 3 is concerned, and as well as your programming is concerned. So we're gonna be talking about the part on user-defined data types. So to start with, what we need to appreciate on user-defined data types is this. We have data types that we already know. Yeah, data types like strings. We have data types like a boolean, data types like integers. We have real. Yeah, all those you already know about these data types already. These data types are called primitive data types because they were already created by the they're already there in the programming language. They were already created before by the person or by the people who created programming languages. So we already know that these are already built in. They're called primitive or built-in programming languages, built-in data types. Yeah, they're built in. They're already there in the programming language that we might want to use, be it Python, be it Java, be it C++. We're already going to be having these data types already in the programming language. So now we are talking about the opposite of these. Now they are the user-defined ones. Now are the ones that the programmer, me, the user who wants to program a system, me is the user, is the programmer. I want to make my own data types. So we call these now user-defined data types, right? It's more like this. The main reason that is why why these types of data types are created is because when we are dealing with primitive data types or built-in data types, they have some type of restriction on how you use them, right? They are limited restriction, or they have some form of limit on how you use them. So when we are now creating our own data types, we are saying we don't want to be confined or to be only guided by these data types that are already created. We want data types that are able to work in the way that we want as the programmer, or that are customized to the program that I might be creating at that moment. So the reason why user-defined data types are created, the main reason is that they allow flexibility, right? They allow flexibility when we are creating our own program. So this is going to be a cornerstone for every programming that you're going to be doing. You are going to create your own data types. Check this part. You are always going to create your own data types whenever you're creating a big system that is significant, not just small programs that you're going to be doing, but whenever you're creating a system that is significant, you are always going to be making use of your own data types, which you're going to be creating by yourselves, right? So the main reason is that you don't want to be restricted by these. They just do not perform all the functions that you might need in your program. So what do? You go ahead and create your own. You create your own programming language. You create your own data type, and that is an example of a user-defined data type. And the main reason why you're doing that is because you want the flexibility that comes along with the user-defined data types. You create something that does what you want. That's basically what we have there. So you see that user-defined data types, they can be split into two mega groups. The two mega groups are composite and non-composite. So some they call them composite. I don't know. So if we're talking about composite data types, we are saying that composite, it means it's a composition. Compose. You're bringing together multiple elements. So a composite data type is the one that makes reference to other data types, either the ones that are built in or the ones that are also user-defined. The main key is that when we are calling them user-defined, we are saying, when we are calling them composite, we are just trying to say that they make reference to other data types. They make reference to other data types. So you'll be asked about this question here. What are composite data types? When you're talking about composite data types, we're talking about data types that do make reference. They make reference to other data types. That's why they are composite. But if they are said to be non-composite now, it means that if they are said to be non-composite, it means that they do not composite. It means that they do not make reference to any data type. Right? That's basically what these do. These do not make reference reference to other data types. So check this part. I want you to understand this part. Composite data types, they make reference, but non-composite, they do not make reference. So if a question comes through and says, what is a composite data type? They just want this part that they're making reference. But if they ask you now, what is a user-defined composite data type? There are two definitions that they're asking there. Why are we calling them user-defined, and why are we calling them composite? Just make sure that you're always going to be mindful of that. And in most cases, this question comes through with 2 marks here. They're saying, what is user-defined composite data types? So you're defining the part why they are called, what they are called user-defined. They are called user-defined because they are created by the programmer. Why are they called composite? Is because they make reference to other data types. So to answer a question, what user-defined composite user-defined data types are, we are saying that these are data types that are created by the user, making reference to other data types. If it's user-defined non-composite, we are saying that these are created by the user because they are user-defined. They are created by the user and do not make reference to other data types. You are supposed to be able to make sure that you pinpoint those areas, yeah? So that's the bigger picture that we have here. Non-composite, they do not make reference. Composite, they make reference to the data types, right? So it is very important now to know how to design now each of these data types now, the composite ones and the non-composite ones. You need to be able to declare or to create them and to see how they are used in the programming language, yeah? Okay, so I'm not going to be moving on to with this, but I think I'm going to be leaving the part that is up there like that. So let's scroll down a little bit. So here they are saying that programmers use specific data types that exactly match a program's requirements. These are what we are calling user-defined. They define their own data types based on primitive data types provided by the programming language. So we're saying that if they are using primitive data types, these are going to be called now composite data types. Why? Because we are making reference to the ones that are already there, or data types that we have defined previously by the program. So we might use other user-defined data types to create composite, or we might use only primitive, or a combination of primitive and other user-defined to create composite. Whenever we're talking about composite, we are making reference to other data types. But the ones that we are referring to do not only restrict us to use primitive. We can also use other previously defined user-defined data types to create composite data types. I hope that is clear. So they are telling us that these are called user-defined data types. User-defined data types are divided into 2 groups, composite and non-composite, of course. Then we are saying that user-defined, these are data types based on a data type that is based on an existing data type or other types of data types that have been previously developed by the program. Yeah, they make reference to other data types. Okay, I somehow do not like this definition because it's defining only based on non-composite, right? So we are saying that these are defined by the user. That's the part that makes sense as far as the user defined. Non-composite, a data type that does not refer to any data type. That's what we just talked about. Enumerated, pointers, and sets. We're going to be talking about these in the section below. So check this part. Non-composite. These are non-composite data types. They can be defined without referencing other data types. You see that part? We are creating them without making any reference to other data types. Right? These can be, so non-composite, they can be primitive or they can be user-defined. I hope you are seeing this part. So a string is a primitive non-composite. A boolean is a primitive non-composite. An integer is a primitive non-composite, because what is making it to be non-composite, it means that it's not making reference to anything, right? And we're saying this can be primitive or it can be user-defined. You get the point? So non-composite user-defined data types are usually used in special purposes, for a special purpose. That's what they are giving us. So examples of these now that are user-defined. So we're talking about the part of user-defined which are non-composite. One, we have enumerated, and we also have the one that is called pointer. These are the only two that you're going to be talking about whenever you're asked about user-defined non-composite data types. We have enumerated and we have pointers, right? So to just explain about those, they are pretty simple. To start with enumerated data types, they are data types that contain no reference to other data types when it is defined. Check this part. In a pseudocode type, we're saying that it contains no reference. I think I need something else. What did they say here on this part? Enumerated. Okay, cool. I want you to take this definition here. Enumerated data types, these are non-composite data types defined by giving a list of all the possible values that is in implied order. So we're supposed to be having an order for the values that are possible. So enumerated, it just means that it's a list of possible values. A list of possible values. That's what enumerated means. Yeah. So we're talking about the part of enumerated, like here we're saying that you just say type, then you give the identifier name for that enumerated, for that data type, then you go ahead and give us the values here in brackets. Just that. Let's talk about the part of for example, a data type that's gonna be talking about the months. The months of a year, we know that there are only 12, yeah, from January to December. So we're saying to create a data type that is enumerated, you just say type and you go ahead and give us the name of the data type, right? T is just telling us that it's user defined, right? You can just say type month, is still okay, right? So they're saying that the types names usually begin with T, right? To aid the programmer to just know that this is the one that they created by themselves, yeah? So if we say type T month, we have January, February through December. This is an example of enumerated data type. Check this part. The values are not strings, so are not enclosed in quotation marks. If they've been in quotation marks, then we are referring to strings now, which makes them no longer enumerated. So the values are not supposed to be coming through in quotes. That's what you're supposed to be knowing as far as enumerated is concerned. That's the very simplest one. It's type, give us the name, then give us the list of the possible values, and you're done. That's enumerated for you. Then when we talk about the part now, and this is how now you create a variable that is of type T month. Check this part. Declare this month. Declare you're being asked to declare this month. So my variable is called this month, that is of type T month. So I can now create a variable that is of type user defined data type that I created that is called T month. So I've just created this month, which is of type T month. And if I want to give a value to it, I'm just going to be saying this month is equals to January. And if I say next month is equal to this month plus 1, I'm now referring to February because they are already in a specific order. I hope that is making sense. So just know that when I create my own user-defined data type, I can now go ahead and create variables that are of the type that I created. So I created a data type that is called T month here, and I can now create variables here that are of type the variable name that I have created, the data type that I have created that is called T month. So this is creating a variable that is called T month, and now I'm now creating a data type that is called T month, and here I'm using now that that data type to create my own variable. Now I'm now customizing my program now. Yeah, you're gonna be asked of this, so make sure that you are noting down what we are discussing here. Then the next thing that's going to be coming through is a pointer, which is again a non-composite user-defined data type. So a pointer now, it just make reference. It is used to reference a location. That's all that you need to know, right? A pointer is just used to reference a location, and in most cases, we're going to be having this sign here to be acting as a what is our indicator that this is going to be a pointer. So you're just going to be saying type, just like what you did when we were creating enumerated ones. You say type, then you give it a name. So type of month pointer, then you give us now this sign to indicate that that is a pointer, which is T month. Yeah. So T month now is a data type in the memory location that this pointer known as a T month pointer is gonna be this pointer can be used to point to. So what you need to know for now is that a pointer is another example of a non-composite user-defined data type, and it's used to refer a memory location. For the meantime, just know that. If we can meet up and just know again how to declare it, but rare are the cases when I have seen a question asking us to create a data type that is called a pointer. But just know that there is another there is a user-defined data type that is called pointer, which is an example of enumerated. It does not make reference to any data type. What it just does, it just references a memory location. That's probably what you need to master as of now. Yeah. So with that knowledge being said, let's jump in to talk about the part of composite data types, which are the ones that are usually most asked, especially the one that is on the first, that is called a record. Yeah. So when you're creating a record, you say type and you're supposed to end type. So make sure that whenever you start with type, then you're then supposed to be ending type. You give us the name of the record that you're creating. When you're creating the name of the record, you give us all the attributes that are supposed to be in that record and the data type that those attributes are supposed to be joining. That's how it is composite. It's referencing other data types. So, what are they saying here? The data type that refers to another data type is to other data type is in its type definition is a composite data type. In chapter 10, the data type for record was introduced. You can just go back to chapter number 10. Was introduced as a composite data type, and this refers to other data types. So we are saying that these are referring to other data types. So go back to chapter 10 and check what we are talking about. So this is the major one that you're supposed to be knowing. Yeah. So we are saying here you just created a data type that is called T record, T book record. Yeah, and it has these attributes. So I can go ahead now and create my own data type, that is my own variable. I can just declare a variable that is called maybe my favorite book. My favorite, that is of type T book record. Right? So this book knows my favorite here is supposed to be having these attributes as an Armangan R5. So what I'm going to be doing here is this. I'm going to be saying my fav, if I want to give values to it now, my fav dot title. You see what's now happening here? My title, my fav dot title, I'm going to be giving it a value now. Maybe Troy. You see? This is now what's happening. I'm now giving it a value for title. So my fav, I've just declared here, when I want to assign values now, these are how I assign values. I give in the variable name dot the attribute. So always variable name dot the attribute that I want to give a value. Always master this because you need to use this information. Attribute here, right? So always variable name dot attribute. Then I use the assignment sign to give it a value. So the value that I'm going to be giving here is supposed to be in conjunction again with the data type that I have just given it here. Suppose that probably number of pages was supposed to be coming through as an integer. Suppose that it was an integer. I was supposed to come through and say what? My fav dot number of pages like this is equal to maybe 5,000, something like this. That's how I was supposed to be giving it, as an integer, not as a string. Yeah? So I'm supposed to be in conjunction with what I have already been given here. I hope that makes sense. And you see that you gonna be using records quite a lot as far as the paper 2 is concerned, even also as far as the paper 4 is concerned. Okay. Talking about that, let's now move on to talk about the next part, which are sets. I rarely see these being asked though, but rather you just need to know about them. So we're being told that a set is a given list of unordered elements. Remember when you talked about the part of enumerated, the values that are possible are supposed to be coming through in a specific order. But now we're talking about sets. It's a given list of unordered elements that can use set theory operation, just like what intersection, just like union as well, and even set difference, of course. So the whole point is this: sets, they do not use type. They are using, gonna be using type. I mean to say type. Then you give us the identifier name of the set. Then you tell us now this is a set of what data type that you are gonna be talking about. I hope that is making sense. So we can talk about the part of type, S letters, set of characters, the data type that is going to be referring to. So everything that's going to be coming through in the data type is supposed to be coming through in order. It's supposed to be coming through now containing this data type. Yeah. Then, so there are two statements that you're going to be using here to define a set. Number one, you are telling us the part that S letter is the name of the set that you're creating. Then you then define now. You define vowels that's supposed to be containing the letters itself. You define, you give an identifier name of these set values that you're going to be giving us. Then you give us the values of those set values. And you tell us that it's containing what? It's of type what? It's of type letters here. So writing letters here is telling us that that's a set. So always know that set is not defined. You do not create a set. You do not declare a set only. You don't create a set with only one line like what we're doing, like when we created record, enumerated data type, and even a pointer. You use two lines whenever you're creating a set. Number one, you tell us the data type that's going to be held by that set that is going to be referring to. And number two, you give us the values that are going to be in that set. So make sure that you are mastering that part, because they will ask you about how to do creating sets. Then the last part now that we're going to be having is the part of classes, and this is where I'm going to be spending much of my time, because classes are very going to be coming through handy in chapter 4. In paper 4, I mean to say. So a class is a composite. Let me just start by the theory part. A class is a composite data type, right? Which means we are the ones who are creating it. Check this part. That includes variables of a given data type and methods. So we have two things here. We have variables. Let me just call these attributes. So a class is going to be coming through with attributes and methods, right? Method can actually be a function or can be a procedure. Always know that part. So it's going to be containing what? It's going to be containing methods. We are saying that the code routines that can be run by an object of that class. An object is defined from a given class. Whenever you're creating an object, it's supposed to be telling us that it's of which class, right? Then several objects can be defined from the same class. We can create so many objects using that one class that you have just created. Like what we do always whenever we have strings, we can create many items, many variables that are of type strings. But when you're creating now a variable that is of type of a class, we are calling it an object. So an object, just treat it as a variable. We can create a variable that is of type class, and that variable can perform all these methods, right? We can use these methods on the variable that we have created that is of type of this class. You understand as we go, but basically just know that whenever we're talking about a class, we're talking about two things. There are attributes, and there are also methods. So one thing that you're supposed to be asking yourself whenever we're dealing with classes: number one, what is the class name? Number two, what are the attributes? Number three, what are the methods? And if you're done with that part, then you are good to go with classes. Yeah. So classes and objects will be considered in depth in chapter 20. And without wasting much time, let's just jump into chapter number 20 already. So chapter number 20, we're going to be doing a lot of programming that is involving classes. And what we want to talk about is object-oriented programming. That is OOP. And anybody who knows programming, anybody who is doing programming, I always tell my students this thing: you have to stop claiming that you know computer science in depth if you do not know how to perform object-oriented programming, because OOP is the cornerstone for all programming concepts that you're going to be doing. Yeah. So I'm just going to be jumping. Okay, I can actually check on this part. Class is a template defined with methods and data of a certain data type. That's okay with me. But a class, just know that it contains these three things. A class name, class attributes, and class methods. So I ain't going to be wasting much time here. I'm just going to be going straight up to the part of coding, and you will do much of the reading by yourself, because I'm not up for that for the moment. So check this part. A class is a template defined. Okay, let me just clear the screen. Okay. I don't know why it's not allowing me to clear the screen. Oh, okay, cool. I got it. So we're saying now, a class is a template defining the methods and the data. So these are the attributes for me. So I'm going to be saying that it's going to be defining the methods and the attributes. The attributes are the data items in a class. Check this part. What is being called an attribute is the data items that are in the class. A method now is a programmed procedure or a programmed function that is defined as part of the class. So a class is going to be containing attributes, and it's going to be containing again methods. So always be able to identify which are the attributes and which are the methods that are supposed to be in that class. You get the point? Of course, with the class name, of course. Then putting data and methods together in a single unit is called encapsulation. So you're gonna be asked about this thing. What is encapsulation? You're gonna be coming through to give us this definition that they gave us here. You're gonna be noting it here. Where did I see it? Encapsulation. There we go. A process of putting data and the methods together in a single unit or a class. So the process of putting data and methods together in a class, we're going to be calling that encapsulation. You need to remember that definition. Right, I'm not up for much talking. You're going to be doing the reading after this because this is going to be an interesting topic. I'm going to be showing you the code way of actually dealing with this. Then after that, you can now do the reading by yourself. So to ensure that only the methods declared are used in the are used to access the data within a class, attributes need to be declared private. This is a key word again. So all attributes are private, but all methods are public. Always know that part. And we need to know how to make them public and how to make them private. So we said a class, when we started, we said that we are supposed to see the class name. We are supposed to see the class attributes, and we are supposed again to see the class methods. Yeah. So at the end of the day, we are having the name, the attributes, and the methods. Yeah. So like if you see in this figure here, the class is shape, and these are the attributes: name, area, and perimeter. And we are being given the data types that these are supposed to be carrying. Then the next thing, we're now being given set this one method, second method, and third method. Of course, there's a method that they did not give us set shape. Okay, it's okay. This might be the method. It's called a constructor. We'll talk about it in a second. So that's basically what we have. A class contains three things: name, attribute, and methods. And all attributes, we just have been told that make sure that all attributes are going to be privately declared. Then all methods are going to be public. So we need to be seeing how we make this private and how we make them public when we are now creating a code. Yeah. So they're giving us more intel here about an object, and they're saying that when writing an object, when writing a program, an object needs to be declared using a class type that has already been defined. So they're telling us that an object now is a variable, more or less, a variable that is of type the class that we created here, the class name that we created here. You'll see that in some seconds. So in some programs, they're calling that an occurrence of an object during execution of a program is called an instance, right? Oh, come on, what did I just do? Oh, come on, man. So it's called what? It's called an instance. So you get again to understand more about this when we are creating our codes. And without even wasting much time, I need to jump to the part where I start programming. Yeah. What happened here? I was on chapter 20, so I passed this already. Yeah? Okay, cool. I need to get into the part of where I start programming now. Did they give me something that I can work with? An employee, right? Check this part. So I can clear this. So here they went ahead to create something here in Python. Here they created a class that is called employee. The class is called employee. So for us to create an employee class, we use the keyword class. So when you say class employee, so this is the keyword to create a class, and this is the name of my class. Yeah. So we now have one element. Number two, we need now to initialize. This is the constructor. The constructor for Python is called underscore underscore init. It's a method here. Underscore underscore. The constructor is a method. So this is the name of the constructor that we're going to be using in Python. And whenever we are creating a method, we use the keyword def in Python. Def for define is a keyword that is used to create a method, or that is a function or a procedure. So they are saying def, which means that they are saying that let's define this what? Let's define this method, and the method is called a constructor. Our constructor is called underscore underscore init underscore underscore. Then every method in Python is supposed to be coming through with self. to indicate that this method belongs to the class that I just created, in which it is indented in. So if I say def underscore underscore init self, it's a parameter that is telling me that it's a default parameter that tells me that this constructor belongs to this what? To the class that is called employee. Even when I create show details, another method, it's containing one attribute by default, which is called self, to indicate that it belongs to the class in which it is indented to. I hope that is making sense. And again, the attributes are supposed to be coming through again with self to indicate that this attribute that is called name belong to this class. This attribute that's called staff number belong again to this class. So we're saying that self is supposed to be coming through as default again whenever you're creating your attributes for the for that class. One thing now that you're supposed to be knowing is this. We already said that class is we already have the name. The attributes are these ones. You see the attributes here. 1, 2. These are the attributes that we have. In here, we took these attributes as parameters. I know this might actually be coming through to be a little bit vague, but you understand as we're going to be going. So the names of our parameters, these are the ones: self.name and self.staff, right? And we are giving them initial values, which are the values of the parameters that we took here. I'll answer a question and I'll explain that in detail. Show details is just displaying the names of our parameters that we have. So if we call show details, it's going to be giving us print employee self.name, print again self.staff number. So we now have name, parameter. The methods that we have here, we have the constructor is our one. Whenever you see def, means that that's a method. So you have one. The first method is called the constructor, which is underscore underscore init underscore underscore. The second method is called show details, right? So check this part. So we already have the name, the attributes. These are the attributes, and we have the methods. Yeah. Something that is not being shown by this is how you make Python, or you make private attributes in Python. When I say, I'm going to be taking this line. When I say self.name is equals to name, this is a public attribute. When I want to make it private in Python, I say self.__name. That's how I make this name a private. So we are just going to be using this way in all our cases. Our attributes are supposed to be coming through with underscore underscore. Then you give us the whatever that you're going to be giving us as its initial value. That's how we make them private. I hope that is making sense. So I'm just going to be taking this and I'll put it in code. Okay, let me just finish it like this. So an object now, I was saying that an object is a variable that is of that type, of that class, of type the class that we just created. We went ahead to create the class that is called what? That is called employee type. That is called employee. This is my variable. This is my class here. So now here I'm now creating my staff, which is a variable that is of type employee. I hope that is making sense. So just know that this now is an instance or is an object that is of type what? Of type employee, because of this part here where they're telling us that's an employee. I hope that makes sense, and I don't want to make this video any longer. I'm just going to be cutting it here, and I will just record the separate video as far as how we create the classes by answering a typical examination question. Yeah. All right.